Hi, thank you for joining. Yeah, I have a shorter version of this title, just Apache Big Data loves Cloud Native. This is what I would like to talk about, and let's start with the Apache part first. So these numbers from the Apache Jira from this year, all of the number of the resolved issues per project, the real resolved issues, so not the duplicate. So what we can see here, first of all, Hadoop is not dead. This is, we can pretty sure. The other thing what we can see here is that the majority of the most popular projects are related to big data. And this is not just because some big companies are working on that, because you see this is just about Hadoop and the number of the unique contributors. So the Hadoop is developed not only a few people who paid for it, but a lot of individual contributors. So it seems to be very popular, the Apache Big Data space. And the other side, the cloud native space or Kubernetes space is also very popular. So this is from the CNCF Kubernetes Project Journey report. And what you can see that there are a huge number of pull requests in the Kubernetes space, and unlimited number. So it's even more popular. So my question is, if the left side is very popular, if the right side is very popular, what is between them in the intersection? There should be a lot of very popular projects there, right? Which can be just used off the shelf. So where are the projects? That's what I would like to try to find in this presentation. That why there is no more project there if both of the sites are very popular. Okay, let's talk about first about the Apache Big Data space. So I had a presentation 1 year ago that how the Hadoop can be started in Kubernetes or Hadoop Ozone. And I think nowadays, all of the projects can be started with some kind of tricks in Kubernetes, with operator, with Helm chart, because most of the problems are very small problems regarding DNS handling or retrying, and they are mostly solved in the project. So everything is fine, but what I'm interested about is not just start a Spark or start a Kafka, but what I would like to get is deploying a full stack which can work together and use each other. Let's say I have some incoming data in Kafka and I'm processing with Spark and saving to Apache Ozone or Apache Hadoop Ozone or Hadoop HDFS. So I would like to deploy and handle this as a stack. And this seems to be missing. So that was the Hadoop part. So let's check the other side of the problem. So what is this? What is cloud native actually? Do you have a good definition? Actually, the problem is that it's very, very hard to define what is cloud native exactly. So maybe because it's some kind of marketing term, not just purely technical term. But yeah, the easiest way is just replace the cloud native expression with a set or search and replace with Kubernetes, right? That's the easiest definition, even if it's not the most accurate. If we are looking for a more accurate definition, this one is from the CNCF Charter. So cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Clear, right? Can you repeat it, for example? So I read it multiple times, but to be honest, there are some other definitions under the CNCF GitHub repositories which says that, okay, cloud native is something like microservice and containers and all together and scaling up and down and something like this. So yeah, it's not very easy to define what the cloud native, but it's also an advantage for me, because in that case, I may have my own original definition, right? If everybody can say what is cloud native, I can also say what is cloud native. The only problem is that if I define cloud native for me, this depends from my view, right? It depends from what I'm doing. So first of all, I should clarify what I'm doing as a disclaimer. That everything what I'm talking about is from one specific view. So my name is Marton Elek, and I'm working on Apache Hadoop, mainly on a new sub-project, which is called Apache Hadoop Ozone. And it's a very nice logo. And this is an object store. So it's something like the S3 and Apache Hadoop HDFS together. So this is a storage, and you can use it as a S3 backend, or you can use it from good old Hadoop file system from Spark, Hive. And the other selling point, it scales way more better than the HDFS. So it can handle a lot of small files, not 10 billions of files. I'm working for Cloudera, and when I have some time, I'm also trying to run these big data, Apache big data projects in different containerized environments. I started with Nomad and Docker Swarm. Nowadays, I use Kubernetes for everything, and this is what I would like to share here. I have also some tool which is required to do it. So what is cloud native for me? Yeah, that's you understand my viewpoint. So I can say that, okay, what is cloud native? This is Apache Hadoop. It's 2.7, but this is a generic Apache download page. So the 3.2, it's very similar. And in Apache, the real release is just the source package, right? That's the real release. It's possible to give convenience binaries for the users. So this is a binary which can be downloaded and can be used. Okay, next question. How can I start it in Kubernetes? Any guess? Yeah, pardon? Just put it to a container, right? Well, I can read all of the documentation, and all of the settings are documented very well. But this is usually the user responsibility to start it in some tricky way, in Kubernetes or Docker Compose or somewhere, right? The Hadoop itself is developed by the developers. It's finished. You can do it your own, what you would like to do. On the other hand, from the Ozone side point of view, what we are doing, I think this is my responsibility to help all of the users to run in different environments Ozone. So Ozone is just, you can download it. There are multiple ways to run it just with a Docker Compose app. There are example clusters with all of the configuration locally. It's very easy to start. There are Kubernetes examples. So this is the documentation. And it's not about Ozone. I think it's about so for me, this is the cloud native approach when we need to support multiple cloud-based environments, not just to start it in Kubernetes or different kind of cloud, but to work together with other projects, with Prometheus, with OpenTracing, with any other projects, which is actually very similar what we have in the Hadoop, right? The Hadoop is an ecosystem, so the HBase and Hadoop can work together, Spark and Hadoop can work together. So this is something is very similar what we have now. But why do we need to work together? That's the next question. And not just because it's fun or it's easier, but this is the AWS console, right? If you need to start a new machine, then with a few clicks you can do it, and you can understand what's going on. And I would like to provide the same user experience, not with UI, because mainly I like the console and I do everything here, but the same simplicity. So I think the cloud native is about the user experience. And the user experience mainly can be achieved with the collaboration. So that's the main reason why I would like to support to run the project, the Apache project everywhere. And I would like to support the collaboration with other existing points. Okay, so that was the cloud native. And we know what is the Apache Big Data Hadoop, and so it's not just about Hadoop, but all of the Kafka, Spark, and all of the similar Apache Big Data projects. So first of all, we need something here in the intersection, right? So we should define the requirements that what kind of projects can be there. It may help us to find the ideal solution. Okay. I have 5 requirements. This is the first one, and I think we already discussed it, right? I wouldn't like to deploy projects. I would like to deploy some kind of stack where the projects can work with each other. So it's some kind of collaborations between the projects. So it's not just about how can I deploy Kafka and how can I deploy storage, but how can they work together with the same configuration. Okay, the next is the fully customizable Right, mainly because I'm a developer, I would like to have the power to set all of the settings which are implemented in the Apache. But this is not just because I'm a developer, so I don't think that we can cover all of the specific use cases with a simplified set. So yeah, some of the projects, for example Hadoop, has unlimited number of the configuration, and it's very, very hard to understand what kind of configuration should be set. And I think it's bad, but the configuration shouldn't be hidden. They should be organized somehow or structured to make it easy to understand, but we need the power to use all of them. So that's the second. Third, this is some kind of packaging, like the RPM. So I mentioned that sometimes I need the Spark and Ozone and Kafka together. Sometimes I just an HDFS. Sometimes, so it's not just about components or projects, but also about generic features like Kerberized cluster. So if I need a secure cluster, I would like to Kerberize and turn on the security all of the projects. So this is some kind of packaging and generic features. And OK, this is the composable feature set. This is the most tricky one. So when I would like to turn on the security, it should be turned on everywhere. And that will be the hardest part, because it means that it's not enough to install one Kafka and one Spark and one storage. But somehow, when I change the storage configuration, all of the other projects, all of the other configurations should be changed. We will see more examples later. And finally, this is the Hadoop configuration. It's XML, because it's a good old project. And we have this code. That's the core side. That's the trick. So this should be copied to everywhere, to all of the components. We have an HDFS side XML for the storage. We have a yarn side XML for the execution. But if we check the containers, for example, so this is one container for the storage. We have the core configuration and the storage configuration. For the execution, we need the core configuration, the storage configuration to use data from the storage, and the execution configuration. What about if I would like to change this storage to another storage? Well, it's not just the storage which should be updated, but all of the execution containers should be updated. So that's the trick. So that's some kind of collaboration between them, right? So they are not just individual containers, but they should work together. OK, so that's the collaboration part. And finally, I would like to support versioning and migration. You know that if the configuration is bad, I would like to roll back to the previous one. If there is a risky configuration, I would like to test it in a test environment or staging environment, and I would like to deploy it to production after that. One option is to do it just to commit all of the configuration to a Git repository. This is GitOps. If there is a tool to convert all of the configuration to a real environment, then it's possible. OK, so this is my dream. This is what I'm looking for. Something which can help to achieve all of these in cloud-native environments. First of all, I'm not sure if they are real requirements, so we should check some existing tool set if they provide something similar to this one. Because if the existing cluster managers have something similar, then it's more or less realistic dream to have something similar in the Kubernetes. As of now, so I'm familiar only the Apache Ambari, which is, I think the develop is mostly stopped when the Hortonworks merged with Cloudera. And there is this Cloudera manager, which is not open source and not Apache project at all. But we can check at least the requirements that, OK, this is a proprietary solution, but it provides some kind of functionality, what we are looking in Kubernetes. So first of all, manage the whole platform, right? All of these management products doing the same. We have a lot of Hive, HBase. So this is what I'm looking for in Kubernetes. So I would like to manage all of them together. Fully customizable. OK, that's, again, just an example. Here you can see that it's structured. So this is a simplified view, and it's easier to find the right configuration. But you always have the option to set any kind of Hadoop or real Apache configuration here. This is the safe at all. So this is what I would like to have, just the power to configure everything. The others are more tricky. So shareable, reusable part usually it's implemented by the different kind of big data management software because they use RPM, but it's very hard to create your own RPM if you are not familiar. So it's not very well designed to get external contributions. The composable collaborative feature set, it's very hard to create something when you install a new, let's say, Ozone, and it couldn't modify the Grafana install or something. Or if it should, it's hard-coded somewhere under the hood. This versioning is usually supported but with database, and all of the configuration are stored in the database. You can roll back, and there are some kind of templates which can be reused. So more or less, the features are valid, right? Because the proprietary tools provide something very similar, more or less. So let's check what do we have in the Kubernetes. So first of all, how does Kubernetes work? Do you use Kubernetes? Hands on if you use. Okay, a few of them. I have a full Kubernetes training in the next 1 minute, but only the part what we are interested about. So let me explain what is Kubernetes from this point of view. So this is actually not Kubernetes. This is a good old web application, and I'm pretty sure you developed a lot, or at least you have seen a lot of this type of application where you have a backend. Usually there is a database somewhere here, but it's not so interesting right now. And we have multiple resources, and usually we have some kind of REST interfaces, for example, or some kind of interfaces here. You can just create, read, update, delete the users, the customers, and the products. And Kubernetes itself, it's very similar, just way more flexible, because you can save everything in the world, or almost everything. And because you can save a lot of type of resources, the only thing what you should do is just group somehow these resources. So usually we have a group, a version group, and under that we have a kind of resource which can be saved. That's all the Kubernetes. So it's a very flexible backend server. For example, this is the apps v1. This is the group, the first version of the apps group. And under that, we have this stateful service. So Kubernetes is nothing more, just a very huge game with YAML files, right? So it's here you can see that apps v1, this is the API version, this is the kind. This metadata, it's very usual to have it, but all of the others depends from the resource. So ideally, you can save any kind of YAML files to the Kubernetes. Yeah, but the only problem is that at the end of the day, we would like to have a running container, right? That's the whole point. So when you save a resource, under the hood, there are controllers who listen on the API server, and if there is a new resource, they will do something. For example, start a container, mount a storage, or something. But the main interface is just saving a lot of YAML files or posting a lot of YAML files for the Kubernetes. So all of my problem here is just creating a lot of YAML files. It seems to be easier. So still, I don't understand why there is nothing on the intersection if it's just a YAML file generation problem. Okay, so let's talk about the patterns. The most popular pattern in Kubernetes is the operator pattern, which means that, okay, if I would like to install, for example, Ozone in Kubernetes, I need a lot of YAML files. Not just one, but a lot of complex YAML files. What about to simplify and post just one? Just the Ozone YAML file. So instead of creating a lot of from this, which defines that, okay, the number of the replicas, labels, metadata, create something like this. It's still YAML files, so it's still the game of the YAML files, but this is just one YAML file with a simplified configuration. That's the whole point. The only problem is here that by default, if I post something, it was saved, but none of the controllers will pick up, right? Because the controllers are trained to handle the original Kubernetes resources. So I need to implement some controller which listens if somebody saves this simplified file and create all of the original resources in the API server. So that's the operator pattern. some custom format, a simplified YAML file format, and under the hood, some controller who can do the right thing based on the YAML files. Okay, what's the problem? First of all, I wouldn't like to say that the operator pattern is bad. It could be very powerful because it's a simplified version of the configuration, right? There is more chance that an average user can understand it. For example, there are operators to create similar resources for Spark jobs, and it's enough to create a simple YAML files to initiate a new Spark job, which is very nice. The problem is if I have only this interface and I have no power to configure it, right? Because I'm pretty sure that after a while, I will have some requirements. Let's say I have an additional SSD and I would like to configure it in an additional store under the storage. Oh, sorry, but it's not supported with this simplified resource configuration. Okay, so that's my problem, right? We wouldn't like to hide the complexity from the admin. We would like to structure somehow and help to understand what's going on. My other problem is that I have some running component here, and the behavior of my cluster based on the state of this controller, or if there is no state, at least based on the version. So when I would like to migrate this resource from one cluster to the other cluster, the behavior depends from this friend, which it's more risky, right? There is something under the hood which does the final deployment. So that's the operator pattern, and these are the most problematic parts, that I have no power to fully customize, and it's a little bit hard to handle all of this versioning. The other parts, it's a little bit easier. For example, this composable collaborative feature set when one component modifies the other configuration, because this application sits inside Kubernetes and can do everything which is magic. So that's the operator. I wouldn't like to say the operator is bad, but maybe this is not the best fit to solve this problem, which is a very specific problem, right? This is not a generic problem to do anything, just to run our Apache Big Data projects as a stack. So let's try to find something, some other tools. We have multiple tools in Kubernetes which can be used to handle all of these YAML files. Helm, Kustomize, Flexible, and the generic question about these tools, that how can we use them, and how the tools work, and how can we achieve our goals, the 5 goals, with the tools. And first of all, I have a disclaimer. In fact, we have 2 tools. The Helm is a CNCF incubating project. You can see that it's very popular and very old. And there is a newer one, the Kustomize, with somewhat similar goals. It's merged to the Kubernetes itself. So if you download the kube control tool, which can help you to handle all of these YAML files and apply them, the Kustomize will be included. And yeah, that's the disclaimer. So unfortunately, the third one is written by me. And I wouldn't like to sell it to you that, oh, that's the tool which solves everything, because there are some obvious differences between them, right? So if you would like to find a project, it's more like a POC, not a project, right? But I would like to use it to show how the different feature set of these real tools can be deconstructed and combined in a different way. So it's more like a research to understand the patterns behind the tools. Because if I can get some features from here, some features from here, and combine them in a different way, then we can understand that what are the limitations here and here. So that's the only thing why I use this flexible tool. So because the patterns are independent from the implementation, we should see the patterns of the tools. So the questions were that how can we use them? And yeah, the Helm itself, unfortunately, I have no internet, so I think I have some, yeah, the Helm couldn't be started locally because I have no access to my Kubernetes cluster. But usually, if you'd like to see it from the user perspective, you need a CLI, the Helm. First of all, you need the Helm. You should start the Helm in it. That's an interesting question. Why do we need it? Because it will install a server-side component, which is one of the weaknesses of the Helm. In the next version of the Helm, it will be removed. Right? It's very similar to the operator. So somebody on the server, it just modifies everything, and it depends from the version. Yeah. And for example, with Helm, it's very hard to use the Helm if this CLI and the server have different versions. There are different kind of problems, errors. So that's OK. But we started. So let's try it out. And after that, we can evaluate how does it work. So this is what we should do. This is some kind of packaging. I'm installing Hadoop from the stable repository and with this name. And I will see a lot of output that, OK, all of the YAML files I created under the hood and saved to the Kubernetes. And it's working. Right, so that's all. And you have an option to customize this package. And you can set variables one by one. Yeah, it seems to be a limitation, right? It's very optimistic. If you install a big data cluster, what do you expect? How many configurations should be set to be compatible with your environment? I expect a lot, actually. And it's not directly supported by Helm. There are other tools which makes easier to set it all of the configuration. OK, and after that, you can see with the Helm list that it's deployed. And in the Kubernetes, we can see that all of the containers somehow started. So that's Helm. How does it work? Well, actually, this is nothing more just a package manager plus a template system. So this is the source of a Helm chart. And this is you can see that this is the YAML files, which is the Kubernetes is about. So, and there are template fragments, which will be evaluated before it's applied. And the additional advantage that there is a package manager, so these YAML templates can be downloaded. So what's the problem here? First of all, this is a YAML file. So originally, it was a very structured format where we have meaning of so all of the lines. So with a structure, we know what does it mean exactly. But this is converted to a text file, right? So if it's a template, this is just a text file. We don't know how can we modify it, so we have just a lot of. So this is the values which can be set from the command line. I can, for example, set this yarn node manager parallel create similar to this web HDFS enabled. OK, so I can modify this one, but what about if I would like to put an additional key here, which is supported by Kubernetes? Let's say I would like to define if the containers should be downloaded all the time or just once at the beginning. Or how can I add it? Right, it's not supported with the Helm chart. Sorry, you can create a pull request. It's an open source Helm chart, ideally. So yeah, that means that it's not fully customizable, right? It's even worse that these are specific to the Helm charts, these settings. So even if I learn the YAML files, and which is not an easy task in Kubernetes because there are a lot of YAML files, but let's say I learned all of the structure, but I don't know how the structure can be modified in this specific chart because it depends from this template. So this customizable, it's definitely it's a wrong part of the Helm chart, and it's not powerful enough. Again, I wouldn't like to say the Helm is bad at all. It's very, very powerful just to install something, just to install an operator, just to install a Hadoop, you have seen. But for this use case, when I would like to have a real cluster, a real stack, maybe it's not the most powerful version. So yeah, we have versioning. The versioning migration support is also, we need additional tools to make it possible to save all of the variables in a file and reproduce the reproduce the state, and we need to have exactly the same state in the other server. So that's also not very good. There is no composable feature set at all. So with Helm chart, you can install Kafka and Spark, but the Spark chart, it's very hard to modify the Kafka. The dependency management is something like to combine all of them to one big chart. In that case, you can imagine how many configuration you have. So this is one tool, and it's nice. This was one of the oldest one, but it doesn't solve all of the problems. So let's check the Kustomize. Kustomize, it's a way more newer tool, and it's more easy. You can guess from the name that the only problem here is make it fully customizable, right? Because we learned that that's the problem with the Helm chart. Let's do something better. So let's try to, let's go to here. Do you see this? Oh, no. Okay, maybe my images can be better than this one. Okay, this is a customized directory. And here I have two directories, the Ozone and Ozone Freon. In the Ozone and Ozone Freon, there are just Kubernetes resources. So if I would check the SCM, so this is plain old Kubernetes, license. This is Apache style of, okay, this is plain old Kubernetes resource plus the Apache license. You can see the API version and the kind, what we learned earlier, and all of the others. Okay. I would like to modify them, right? Because it's very good to have the example. But for example, I would like to change the version of the Docker containers, which are somewhere in the YAML files. So I need some kind of transformations. These are, what is this, which is big enough, but you can, yes. So these are transformation definitions. So it means that I need to replace in one of the YAML files, I don't know what, we will see it later, the spec template spec container 0 image. So it is the first image under the spec template spec. So this is structured, right? This is not just a dump text file. We can point to the right point in the structured YAML file. And I would like to change it to build Ozone. This is my new image name. OK, and I have customization YAML file, where I need to say that, OK, these are the directories. Please use all of the original Kubernetes YAML files, because I love the YAML files. Please change the prefixes. And after that, I'm defining that, OK, I had a apps v1 stateful set, and the name, if the name is OM, like Ozone Manager, the image patch all YAML file transformation should be applied. So this is something more customizable, right? This is it's called Kustomize, right? So Kustomize build will generate a lot of YAML files. So these are the real Kubernetes YAML files, the result of the transformation. And somewhere in the init containers, you should see that the image has been changed. So that's all. You have an original set of the YAML files, transformation, and the result. OK. Yeah, we have seen this one, and this one. How does it work? Well, it's very easy to imagine because it's nothing more just a transformation locally, right? It's just a simple Golang application, reading files, finding the right transformation, applying to the YAML files, and saving it to the end. So there is no magic. It's very, very easy. And fully customizable, right? This is what we started to use it. I can change anything. If you come to say that I would like to change it to make it deployable only on this specific node, I can modify. I can add an additional transformation. I can manage the whole platform together, because when I say customize build, okay, in the customize YAML, I can just include Ozone, Spark, Kafka, everything here, and all of the YAML files will be included in the result from multiple directories. So it's very nice. There are shareable, reusable parts, right? This is what we have here. We have Ozone, Ozone Freon, the subdirectories actually. And you can download it from GitHub repositories as well. So you can, there is some kind of remote support as well. But the problem is that it's very hard to. So this is too YAML for me. What about if you would like to change the image file for your own install? You should create this image patch YAML or download a similar transformation. You should modify your value to your image name, and you should say all of the files should be modified. Which files? You can check it from the source, but so this is not something. It's not user friendly at all, right? If the cloud native is user experience, this is not user experience at all. So the problem is that the rules are not reusable and they are not packaged and they can download. I would like to provide something which is easy, and it should be enough to say I need an Ozone and Kafka and do all of the transformation to have a secure cluster. That's what we need, I think. And it can be versioned very easily, right? Because this is a game with all of the local files and nothing more. So let's check this experiment. So I have no internet for some strange reason. So I would like to do something which is similar to the internet. Okay, flexible. Okay. So this tool search for, I need to make it smaller. So first of all, I'm interested in what kind of applications are available. Helm chart uses some very specific repository format. In fact, this is a GitHub repository search. If you put the right topic, it will be displayed. Okay, let's go forward and add the infra means that some kind of infrastructure related, some dashboards and monitoring, and Ozone is some kind of Ozone related definitions. We can check that what kind of applications, which usually just directories with Kubernetes resources. Okay, I have a lot of Grafana, Jaeger, Minio, Prometheus, and Ozone. So ideally there should be Spark, Kafka, all of them are here. You can see that I have some local cache and I have just directories under the hood. And I can add, for example, the Ozone. Okay, Ozone Freon, which is a load generator. It could be, no, it can be bigger. And I can add some Prometheus, yeah. In fact, this is just, it created a very easy file that what Git repositories should be downloaded and which directories should be used. Okay, and all of the files are generated. So it's very similar to Kustomize. So the Kustomize itself can be improved to use something like this. But we have seen that we have this packaging from the Helm chart, and we have the structured YAML file processing from the Kustomize. So these are the patterns which should be reused somehow. Okay, these are the transformations. So earlier we had this replace in Kustomize. Here, the interesting part is that Ozone itself provides ready-to-use transformation. And this is the level what I would like to provide, that, okay, if you would like to use memdisk for the storage, because you would like to just play with the Ozone, then it would be enough to add this Ozone memdisk transformation for all of the, where is this? You can see just the new lines. Okay, let's see. So you can put, unfortunately, we can't see the original lines of the flexible, which was visible earlier. So we can just put additional transformations to here to use the empty dir transformation, or this is an image transformation, which means that the image should be replaced, but only for this one. But again, I wouldn't like to sell this tool. I would like to say that the missing part to have something which is powerful, the Apache Big Data, is something which we can just combine all of the resources and modify based on high-level rules and not low-level rules. So some kind of collaboration. yeah, you can see that I regenerated all of the resources, and the empty dir is just added somehow because I activated the empty dir transformation. So this is this was the question, right? That why there is nothing here in the intersection, and I think the key is the collaboration for both of the sizes, both of the sides. So in the Apache project, we already started to create some. So originally, we have this collaboration between Spark, Kafka, and all of the tools. But we should improve it, right? To make it easier to work together with all of the other tools, monitoring, and make it easy to run our projects in cloud-native environments. But the other side, I think we also need to invent new tools which can support this kind of collaboration between the projects, or improve the existing tools, improve the Kustomize, for example, to have this kind of power to define the big configuration set and handle all of the projects together as a stack. And they are not there, actually. And I think that's the main reason why there is nothing here. But I would like to definitely see a lot of different kind of projects which can solve this problem. Okay, that was all. Thank you very much. If you have any question.
Questions?
When deploying big data tools to Kubernetes, have you observed any slowdowns or reduced number of IOPS operations?
It depends how do you use it. I'm working on storage, right? So yes, Kubernetes provides a lot of possibility to use network storage. But if you deploy storage itself, I'm pretty sure that you should use local disk, right? Local SSD or local spinning disk. And in that case, it's the same because it's just mounted. It's a bind mount. So no, it's typically if you use in the original way how the storage should be used, then it should be the same. If you start to use NFS under the Hadoop, for example, I think that's a performance degradation even without the Kubernetes, right? If you put everything under a storage system to a network file system. So, but typically, no. In the network, there are multiple hops, but I didn't notice. So we did performance tests in Kubernetes and non-Kubernetes, and all of the problems were bigger than this overhead. So the problems were independent from the environments.
Thank you.
Any other?
Hello. We've been working with Hortonworks and with Ambari for a long time, and
yeah,
it's funny to show how many. Sorry, is it fine? It's fine. Yeah, it's funny to see how many tricks are inside the Hadoop environments. I mean, when you launch a process, the process itself knows if the data is close to him. And in this kind of scenarios, he goes directly to the disk itself, using short circuits and these kind of things. So when I see the Kubernetes approach, I have a lot of doubts about this kind of affinities and these kind of tricks. And so,
yeah, sure.
What's your experience around it?
Yeah, so there are multiple questions here. So this is not an Ambari trick, actually. This is a good old Hadoop trick to do the short circuit read from the execution to the storage. And let's talk about first the Ambari. So there are some additional values from the Ambari which were not mentioned here. For example, logging, monitoring, all of these. But I think the benefit to use the cloud-native environments that you can get out of the box more powerful tools, Prometheus, Grafana, or anything. So there are a lot of tools which can be easily used if they are integrated. And the integration usually is just a few lines of code. So that's some features from the Ambari which can be replaced The next question.
Yeah, but
is,
I'm talking, sorry, but I'm talking about the approach of Hadoop ecosystem itself, in which being in the same box is quite important.
Yeah, so the data locality itself, I think it's a separated question. So there could be other tricks, and some of the tricks should be work in container. Data locality, it can be solved, but what we see that a lot of customers would like to create separated execution and storage cluster and wouldn't like to use the data locality at all because they have a very, very fast network. I'm not sure if this is the best approach all the time, but this is the movement where the storage, so the customers would like to manage the storage in a separated way anyway. And in this case, it's not a question. So that's the data locality. It's a very tricky question. By default, this is the reason why is it not supported. But I have seen some demos where the Spark itself modified to support data locality on Kubernetes on top of some annotations. So it's possible, but it's more tricky. And in Yarn, it's not supported at all, I think, inside containers. So, but I think so that's one specific, very hard question. So it's a very good question. But I think there are a lot of other tricks which work as before. But yeah, the advantage of the Ambari is that it has a lot of time behind them, right? It learned a lot of things. So right, if I would just create something locally, it's not equivalent from business point of view because I didn't run it in 10 years or something like this. So yeah, but I think the same can be achieved with enough resources in different way after a while, yeah.
Okay, thank you.
Any other?
I guess it's a similar question, but for example, I used Helm charts to deploy Kudu on Kubernetes, and some of the problems I had were with things like Kudu using NTP for transactional consistency, and being cloud native, adds that extra layer away from the system, which means that I had a lot of trouble. I had to use the hybrid clock, and that lost consistency. Did you experience any of those problems, and how do you think we should solve that especially for database transactional systems?
You see a different time inside the containers and outside the containers.
Exactly.
I haven't seen this one, but there could be. So, that in an HDFS storage, it's more database specific.
Right.
I think there should be. To be honest, I don't know. I think there should be some method to mount the right /pros. So there should be the same time. I don't understand why so if the NTP is synchronized on the nodes, I think the same time should be visible in the containers.
No, I think there's a specific problem with the way. Maybe we can.
Okay, yeah. So.
Any other? Okay, so let's thank the speaker again.
Yeah, thank you.